Hello and welcome to this video on deriving hourly temperature in RH in ForecastBuilder. I'm Ted Ryan, the SU at WFO Fort Worth, and I'll be going through this with you. The Analyze Adjust GUI will look different depending on if you're a site in a non-mountainous WFO and or if you forecast max RH and min RH to create the hourly RH and dew point. The typical office GUI is on the left and is simpler than an office that uses snow level and derives the hourly RH TD too. This module will discuss the highlighted buttons, what they do, how the algorithm creates hourly temperature and or RH from max and min values, and why there are some issues with the MBM data that ForecastBuilder is correcting. But first, let's talk a little bit about hourly temperature and max and min temperature. There is a myth among forecasters that hourly temperature should match the max and min temperatures in the GFE forecast. That's not actually true. The hourly temperature forecast in the GFE is a top-of-the-hour forecast, not an average or a min or max temperature that hour, just the value at the top of that hour. This graph shows how many degrees above or below the top-of-the-hour temperature is from the max and min temperature. As you can see, when the diurnal range is small, the left side of the graph, the hourly temperature is very near the day's max and min temperatures, which makes intuitive sense. But as diurnal range increases, the hourly temperature should be on average a little less than 1 degree above the min temperature and below the max temperature. So, as you're probably aware, most offices forecast on editing max T and min T grids and then derive the hourly temperature from that data. The NWS diurnal procedure is a long-standing method for many offices. It uses a cubic spline curve to calculate the best fit for hourly temperature data from CLIMO, MOS, or MBM data. The disadvantage is that the output from this method is often unreliable during low diurnal ranges, where unrealistic speckling occurs. It also broad brushes temperature changes associated with sharp cold fronts or precipitation. And it also tries to perfectly match the max T and min T, which over the years has produced a nationwide bias. The graph shown here is the bias of our hourly temperature grids versus the MBM. You can see that the NDFD has a high bias around the time of typical max temperature and a low bias around the time of min temperature. The MBM does not have this bias. So how does ForecastBuilder's method to create hourly temperature from the min and max work? It uses the MBM's hourly temperature forecast to calculate the ratio of each temperature at each hour to max T and or min T, and then applies that same hourly ratio to your forecast max T and min T to make your hourly temperature. In this example, notice we've thrown a curveball into our diurnal trend here, and we have a strong cold front forecast early on the second day forecast. This method of making hourly temperature seems simple enough, but what if you make a change to the max T or min T forecast? In this case, let's imagine we're lowering our min temperatures. When a change is made, it's going to adjust those hourly ratios. It's going to keep the original MBM ratio near the hour where the min T or max T is forecast to occur, but it's going to adjust those other hours ratios in a way that makes a smooth handoff from max to min temperature and then back to max temperature again. The result is that we can draw a new hourly curve that incorporates the changes to any max T or min T forecast, but it still has its roots in the MBM trends. See here, our new hourly temperature forecast is now cooler to match our cooler min temperature forecast, but we've still got the same trends of a strong front occurring in the morning of day 2. The advantages of the ForecastBuilder hourly T method are that the accuracy and verification of hourly temperature greatly improves. The other big advantage is that because each grid point is evaluated independently, it's much better at showing sharp temperature changes in the diurnal trends, or even handling different diurnal trends on the same grid domain. There are 3 issues with the MBM data. 2 of these issues the new ForecastBuilder algorithm will address. The third will require your awareness and intervention. Beyond 36 hours, the MBM only has and provides data at 3-hour resolution. Thus, the max may occur at 22Z or 23Z, not at an hour where we have data like 21Z or 0Z. The second issue is that the MBM temperature and MBM max temperature and min temperature use different bias correction methods. This means that hourly temperature from the MBM may be 2 to 4 degrees below or above max T and min T, respectively. On days with highly uncertain cold front passages, I've seen this as much as 8 degrees. Again, ForecastBuilder's method addresses both of these issues, which we'll explain again on the next slide. The third issue with NBM data that most forecasters are not aware of is that the NBM max-T and min-T cover all 4 time zones, but the WFO max-T and min-T is over a smaller period as defined in the NWS directive. For example, the NBM min temperature time range goes to 18Z, while your local min temp time period does not extend that far out in time. As a result, a common problem in the Central and Eastern time zones is that the NBM min temperature will be too cold when a strong cold front arrives during the morning hours. Forecasters will have to be situationally aware of this and change max-T and min-T grids to better match a forecast for their local verification. So here's how ForecastBuilder addresses those first 2 issues. We don't actually use the true hourly temperature to max-T or min-T ratio at the time of the highest or lowest temperature. We adjust this to get this near 1 degree for most locations on the grid. This extra boost will help your hourly temperature forecast be more accurate and results in better forecasts for elements like apparent temperature. But this final bit of matching isn't always done. It will not work in some situations where there are low diurnal ranges and the time of the min and max temperature vary by several hours because it's only a degree or 2 difference, and the forecaster has edited max-T and min-T grids to increase the diurnal range. The result is a grid with some speckling, like the one shown here. The current solution, and we're going to continue to explore better ways around this, is to not do that final matching when the times of the diurnal highs and lows vary wildly across the CWA. Instead, ForecastBuilder is going to output a message like this that also colors grids orange to let you know that the hourly temperature is more than 3 degrees from the max-T or min-T at that period. The purpose of this messaging and the grid highlight is for situational awareness only. Sometimes no action is needed, and these hourly temperature grids will be fine for your IDSS needs. Other times you may wish to create hourly temperature manually, or run the old NWS diurnal procedure to see if that will work for your needs. In the GUI, you'll have a check max-T and min-T consistency button, which will run this 3 degree check that we just discussed. It will also check to see that max-T is not below the highest hourly T values, and that min-T is not above the highest hourly T values. If so, those grids will be shaded pink or blue. Again, neither message or flag will always require an action on your part, as they are situational awareness messages. But in the case of pink or blue grids, you may not want the hourly temperature values to change and overwrite your max-T and min-T, because that's what's going to happen in the integrity step. An example of wanting to let hourly T change your min or max-T forecast maybe because you put in the obs grids, and the max-T and min-T forecast need to be matched to those temperature obs. Likewise, you may not want that 3 degree difference between your hourly temperature and your max-T and min-T if you need a good hourly apparent temperature or RH forecast for that day. So when would you use these buttons? It's a good habit to run the derive hourly T from max-min every time you are in this step, even if no changes were made to the max and min forecast. This will help correct the NBM's hourly temperature forecast so that it's closer to the max-T and min-T. The check to max-T, min-T consistency function will run automatically after the derive hourly T from max and min button is pushed, and when you proceed to the next step. This will provide you situational awareness of any problem areas of the hourly temperature forecast that may need closer attention. The check max-T, min-T consistency button can be pressed at any time, but you may find that you rarely invoke this button on your own. If you go through the Analyze Adjust step without running the derive hourly T from max-T, min-T function, and there is a consistency issue detected, you'll get this pop-up box asking if you want to run the derive T function now. Finally, typically Western offices use max RH and min RH to create hourly RH and hourly dew point. If so, you'll see that RH will be included on your button label. The algorithm functions the same as the temperature, except instead of using T and max-T, min-T to calculate the ratios, it uses RH and max RH and min RH. Unlike temperature, there is no final adjustment performed to the hourly RH near the max RH and min RH values. The hourly RH and dew point calculations will run immediately after the temperature grids are created. That concludes this module. If you have any questions or feedback, the contact information to the ForecastBuilder team is on this slide. Thank you.